Hi guys, let's look at the next exercise, exercise 8C. We are on the chapter remainder and factor theorem. But before we start, let's quickly revise what we did in remainder and factor theorem. Remainder theorem says that if we divide a polynomial, in this case, let's take the example of x square minus 5x plus 8. Let's say I'm dividing this by, let's say, x minus 2. If I need to figure out the remainder when this is polynomial is divided by x minus 2, we can figure out the value of this expression when x is equal to 2. That'll give us the remainder when this expression is divided by x minus 2. So if I put the value of x is equal to 2, this will give me 4 minus 10 plus 8, which means the remainder will be 2 when this expression is divided by x minus 8. So if you want to figure out the remainder, then you don't need to actually divide. You just need to put the value of x minus 2, in this case x is equal to 2, in the given expression. That'll give you the remainder. Now what did the factor theorem say? Factor theorem said that if remainder is 0, then x minus a, which is in this case x minus 2, is a factor. So let's look at an example. Let's say x square minus 5x plus 6. So if we need to figure out when it is divided by x minus 2, whether x minus 2 is a factor or not. So if x is equal to 2, let's figure out the value of this expression. F2 would be equal to 4 minus 10 plus 6, which is 0, which means x minus 2 is a factor of this given expression, whereas x minus 2 is not a factor of this given expression, but it leaves a remainder of 2. That's what basically the remainder and factor theorem helps us figure out. Without actually dividing, helps us figure out whether it's a factor, and also helps us figure out what will be the remainder. Now let's go ahead and use factor theorem to factorize a given polynomial. Last year we did factorization in class 9, where we factorized quadratic expressions using various methods, grouping and splitting the middle term. Here we will be using factor theorem to factorize polynomials of maximum power 3. So we will be looking at expressions, for example, x cube plus 2x square plus x minus 5, something like this. We will be able to factorize an expression of maximum power 3. Now how do we do that? First, we try and figure out the first factor. And how do we figure out the first factor? We use it a trial and hit and trial method. So how do we use a hit and trial method? We figure out the values of x which will satisfy remainder is equal to 0. So let's look at an example. Let's say 2x cube plus 5x square minus 11x minus 14, right? So this is the given expression. Fx is equal to 2x cube plus 5x square minus 11x minus 14. Now we do hit and trial method with the following numbers only, which is 1 to 3 and negative 1 to 3. So in your syllabus, your hit and trial will be restricted to the value of x being 1 or 2 or 3, or x is equal to negative 1, or x is equal to negative 2, or x is equal to negative 3. So the first one we do hit and trial method. So let's try x is equal to 1. So if x is equal to 1, this will be 2 into 1 cube plus 5 into 1 square, that's 5, minus 11 minus 14. This is not equal to 0, which means 1 is not a factor, which means x minus 1 is not a factor. Let's try x is equal to negative 1, right? So let's try x is equal to negative 1. This will be 2 times 2 into 1, negative 1 to the power 3, plus 5 times negative 1 to the power 2, minus 11 times negative 1, minus 14. That's negative 2 plus 5 plus 11 minus 14. This is 16 and this is negative 16, 0, which means therefore x plus 1 is a factor. Now that we figured out x plus 1 is a factor, we will divide this given expression by x plus 1, and which will give us a quotient. Now in this case, the quotient will have a power of 2 because this is power 1, which is dividing power 3. So now once we divide it, we will factorize it even further. Let's solve some questions. This concept will become much more clear. So let's look at the first question which we do, which is question number 1, part 1. It says, using the factor theorem, show that x minus 2 is a factor of the given expression. Okay, so let the expression be fx is equal to x cubed minus 2x square minus 9x plus 18 using factor theorem. What we have is it's already given x minus 2 is equal to 0, which means x is equal to 2. So we'll figure out the value of the expression when f is equal to 2, or rather when x is equal to 2. So that will be 2 cube minus 2 into 2 square minus 9 into 2 plus 18, which is equal to 8 minus 18 plus 18, which is equal to 0. So since f2 is equal to 0, therefore x minus 2 is a factor. So we've done the first part, which is we figured out that x minus 2 is a factor of this given expression, which is fx is equal to x cubed minus 2x square minus 9x plus 18. Next, now that we figured out the first factor, let's divide this given expression by x minus 2. So the expression is x cubed minus 2x square minus 9x plus 18. We are dividing it by x minus 2. So that's x square. That'll give me x cubed minus 2x square. I subtract. This gives me 0. This gives me 0. I bring down. That's negative 9x plus 18. I multiply it with negative 9 because negative 9 into x will give me negative 9x, and this is plus 18, which is 0. So what we have is x minus 2 multiplied with x square minus 9. This is of the form a square minus b square, which means that can be written as x plus 3 multiplied with x minus 3. And we write the final answer in the answer form, which is the multiplication of these would give us x cubed minus 2x square minus 9x plus 18. So these are the three factors that we figured out of the given expression. So they asked us to factorize it completely. We can't factorize it any further. Had you left your answer here, you would have lost 1 mark because this x square minus 9 can be further factorized. Good, let's look at the next question. In this question, we were already given one factor. When we do further questions, we will still have to figure out the first factor on our own. So this is question number 1, part 3. It says, using factor theorem, show that 3x plus 2 is a factor of the given expression. So fx is equal to 3x cubed plus 2x squared minus 3x minus 2 using factor theorem. What we have is 3x plus 2 is equal to 0. This gives us x is equal to negative 2 by 3. Let's figure out the value of the expression when x is negative 2 by 3. So that would be 3 multiplied with negative 2 by 3 cube minus, not minus, plus 2 multiplied with negative 2 by 3 whole square minus 3 multiplied with negative 2 by 3 minus 2. So that's 3 multiplied with negative 8 upon 27 plus 2 multiplied with 4 upon 9. This is plus 3 and 3 gets cancelled, 2, and this is minus 2. Plus 2 minus 2 gets cancelled. This is 3, 1, 3, 9, and this is negative 8 by 9, and this is plus 8 by 9, which is equal to 0. So since remainder is 0, therefore 3x plus 2 is a factor. Now that we figured out 3x plus 2 is a factor, we need to factorize the expression, which means we'll divide this expression by 3x plus 2. Let's go ahead and divide. What we have is 3x cubed plus 2x square minus 3x minus 2 getting divided by 3x plus 2. So the first term will be x square. 3x into x square will give us 3x cubed. 2 into x square will give us 2x square. Subtract, this becomes 0. In the what we bring down is negative 3x minus 2. Let's multiply it with negative 1. So 3x into negative 1 will give me negative 3x. 2 into negative 1 gives me negative 2. This is 0. So we have 3x cubed is plus 2x square minus 3x minus 2 is equal to 3x plus 2 multiplied with x square minus 1. since we need to factorize it completely, I notice x square minus 1 is basically of the form a square minus b square, which means it can be factorized as x plus 1 multiplied with x minus 1. So that's our final answer. This is the final factorization of the given expression 3x cubed plus 2x square minus 3x minus 2. That's our final answer. Both the parts done. We've shown that 3x plus 2 is a factor and we've factorized it completely.